Hey guys, welcome back. Today we're going to be over Unit 10 for response questions. So first we have a 35-gram sample of non-electrolyte is dissolved in 120 grams of water. The solution freezes at negative 4.21 degrees Celsius. Calculate the molar mass of the substance. So for this problem, you're going to want to remember your freezing point depression formula, which is change in freezing point equals constant, freezing point constant times molality. So your change in freezing point is 4.21. And your constant for water is 1.86. And your molality is going to be molality equals moles of substance, moles of solute divided by kilograms solvent. So we don't know the moles of solute, but we do know the kilograms of solvent. So we know that it is 120 grams, so that would be 0.12 kilograms. So if we isolate moles, we're going to have 0.21 divided by 1.86 equals, and then we multiply by 0.2. Moles equals 0.27. So we're looking for molar mass. So we know the mass of the substance. So we just say 35 grams over 0.27 moles. And that will give us 129.63 grams per mole. Okay. And for part B, we have equal amounts of chlorine and sulfur are placed into a container and allowed to escape through a small hole. Which gas will escape faster, and how much faster? So for this one, we're going to look at the ratios of molar masses. So we're going to have the rate of, let's bring up the table real quick. Alright, so chlorine gas is 35.45. So rate of chlorine leaving over the rate of sulfur leaving. And we're going to have the opposite. So the molar mass of sulfur over the molar mass of chlorine. So you're just going to divide that. And you get 0.95. So you're just going to do 1 over 0.95. And you get 1.05. So since sulfur has a smaller molar mass, it's going to escape faster. And it's going to escape by 1.05 times faster. Alright, on number 2. The normal boiling point and freezing point of an unknown substance are 62.4 Kelvin and 55.2 Kelvin respectively. The triple point is at 52.3 Kelvin and 0.64 atmosphere. Use the data above to draw a phase diagram. Should say for the unknown substance. Label the axis and label the regions in which solid, liquid, and gas phases are stable. On the phase diagram, show the position of the normal boiling point. So for this one, we're drawing a phase diagram. So this is going to be temperature, and this is pressure. And we're going to start off around 50. We'll say 65. And for pressure, we'll just go 0, 0.5, 1, 1.5. Alright, so we know that normal boiling point, so that's at one atmosphere pressure, is 62.4 degrees Kelvin. Just 62.4 Kelvin. So that's going to be right here. That's the boiling point. The freezing point is at 55.2. It's about right there. And also, the triple point is at 52.3 Kelvin, around here, and 0.64 atmosphere, so right there. So phase diagram is going to look like something like this. Okay. So describe any changes that can be observed on a sample of solid argon. Should say unknown substance. When the temperature is increased from 35 Kelvin to 120 Kelvin at constant pressure of 0.5 atmosphere. So we have from 35 Kelvin, it's going to be a, what's that going to be? Anyone? A solid. It could be a solid at 35 Kelvin. And then when it crosses over to 120 Kelvin, it's going to be a gas. So solid to gas. And that is called sublimation. That's what sublimation is when it's a phase change from a solid to a gas. So next, describe any changes that can be observed in a sample of liquid substance when the pressure is reduced from 10 atmosphere to a constant temperature of 100 Kelvin. So when it gets dropped, so this is saying when it goes from liquid to gas, and that is called vaporization. Alright, that's number 2. For number 3, samples of carbon monoxide and carbon dioxide are placed in 1 liter containers at the conditions listed below. Carbon monoxide, 2 atmosphere and 25 degrees Celsius. Carbon dioxide, 1 atmosphere and 25 degrees Celsius. Indicate whether the average kinetic energy of CO2 is greater than, equal to, or less than the average kinetic energy of the carbon monoxide molecules. Justify your answer. So for this, we need to remember that kinetic energy is only affected by temperature. So they're both at the same temperature. So the average kinetic energy is going to be equal to. Okay, indicate whether the root mean square speed of the carbon dioxide molecules is greater than, equal to, or less than the root mean square speed of the carbon monoxide molecules. Justify your answer. This is asking whether the average speed of carbon dioxide, how it compares to carbon monoxide. That's what root mean square speed is, the average speed of all the molecules. And so the average speed of carbon dioxide is going to be lower because its molar mass is higher. So if you remember, lower molar mass equals higher speed, so less than. Okay, and finally, indicate whether the number of carbon dioxide molecules is greater than, equal to, or less than the number of carbon monoxide molecules. And so this is comparing the pressures to each other. So higher pressure is going to be more molecules because more molecules are colliding with each other, more collisions. So there's going to be more molecules. So the carbon monoxide's pressure is 2 atmosphere. Carbon dioxide's pressure is 1 atmosphere. So carbon dioxide has a lower pressure, so there's going to be less molecules. Okay, and that is all. If you have any questions, please comment down below. I'll see you next time.